So let's first talk about the implementation of reliable broadcast. So for reliable broadcast, as well as for the uniform reliable broadcast implementation that we will discuss later, we won't be dealing directly with perfect point-to-point links, but we will rather assume that we already have access to the implementation of best effort broadcast primitive. Okay, so the implementation of BEB we have just seen in the previous slide, right? So we have BEB implemented. So now we basically can use it as a component, as a black box, in order to implement stronger services. And this is what we are going to do now. Okay. So we're going to use this instance BEB of best effort broadcast. The algorithm implementing reliable broadcast we will consider is called eager reliable broadcast, and this is the algorithm 3.3 in the textbook. So now we have one state variable here. It's called delivered, and it is initially an empty set. So delivered set is going to be used to avoid duplicates. So we can satisfy this no duplication property that we need for reliable broadcast. Okay, so now to broadcast a message, what we do, we simply trigger the broadcast request on this BEB layer that we assumed we have access to. Okay, so this is what we gonna do here, and we send a message of type data, and this is the actual message, and we also include our own ID here in the self variable, self attribute. Now the most interesting part is the handler of message delivery, which is invoked whenever we get the indication from BEB that a new message has arrived. Okay, so now what happens is that we first check if this message, whether this message was already delivered, and if it was delivered, that we basically don't execute this code, which among other things will trigger an indication, local delivery indication at the process. So that basically allows us to eliminate duplicates, not to deliver a message more than once. Okay, so now let's assume that we get a message, and this message was not previously delivered. So it is not at the moment in the delivered set. So here is what's going to happen. So first off, we do add this message to the delivered set. So next time we get this message, we won't deliver it again, avoiding duplicates. Then we deliver the message to the upper layer, to the application. And here in this line is actually something interesting is going to happen. And this technique, which is applied here, is called message echoing. So we deliver a message that we received from BEB, and then we also trigger another broadcast of the same message. So we basically echo the message again to everyone. And why are we doing this? So that's the great question. So just think about it for a moment. So the reason we do this echoing is because we want to satisfy this stronger agreement property that we discussed that reliable broadcast offers. So a process gets a message from the sender, but the process can't actually know whether the sender is correct. So maybe this process is the only one that received a message M, and no one else is going to receive it directly from the sender because sender just crashed. So now, if this process remains correct, it must also ensure that everyone else will get this message, because otherwise we are not going to satisfy, you're going to violate the agreement property of reliable broadcast. And to ensure that, we have to trigger this extra broadcast here. So we need to echo this message again to everyone else. Okay? And so in that scenario that we just discussed, that the sender crashed and this process is correct and it actually delivered the message, by doing this rebroadcasting or echoing of a message, if this process remains correct, it is guaranteed that all the correct process will get this message, and as a result we will satisfy the agreement property of reliable broadcast. Okay, so this echoing technique is actually quite important, and it will reappear in other algorithms that we will be looking at as well. So now let's see quickly how we can prove correctness of eager reliable broadcast. Basically, that eager reliable broadcast is a correct implementation of the reliable broadcast abstraction. So first, if a correct process P broadcasts a message, then P will eventually deliver this message, and that follows just directly from the validity property of BEB that we are using to disseminate the messages. Okay, so validity is actually simple. Now, node duplication is a bit more involved to show, but it is also simple. So what happens with node duplication is once M was delivered once by a process, delivered for the first time, it will enter this delivered set, and therefore whenever M is delivered by BEB again to the same process, the test in the handler of the BEB delivery will fail, and therefore we won't execute the block of code in the true case of that test, and that will imply that M will actually not be delivered. Okay, so now duplication is also quite simple to see. So no creation is trivial because it follows directly from the no creation property of best effort broadcast that we are using for disseminating messages. So agreement is the most interesting property to show, and it is as follows. So if a correct process P RB delivers M to the application, then, as we discussed, it will also echo M via the BEB broadcast primitive. Now, by validity of BEB, M will be eventually delivered to all other correct processes, and all these processes will also reliably RB deliver M, unless of course that they already have done so. And so this echoing by itself, along with the validity property of best effort broadcast, is what ensures that agreement property is satisfied.